So I was trying to think of what role I was playing at a conference like this, and my initial thought was maybe I was like kind of one of those pharmaceutical reps at a doctor's conference, where all the doctors are kind of doing the kind of really serious thinking, and then the kind of drug rep comes and offers sort of some very specific bespoke treatment that they're selling that's from their particular kind of neck of the woods for some very specific problems that the doctors might have, but they've kind of got the much broader picture. And then I thought maybe a more flattering comparison, staying in the medical theme, was kind of when doctors have some sort of enormously complex patient with a bunch of serious disorders, and they get a consult from a particular person, a rheumatologist or something like that. So I'm kind of thinking maybe that's the kind of role I've got here. And the reason I say that is that I'm going to be trying to answer what I take to be one half of the questions that arise when it comes to thinking about Chance-Credence principles. There's been a lot of very interesting stuff said, I think, on the first half of these questions, and I'm going to try and talk a little bit about the second half of the question. And in a way, you might sort of come to this, particularly metaphysicians and philosophers of science and philosophers of physics and so on, might come to this a little bit more interested in the first half of the question. And I'm going to try to argue that there are nonetheless really interesting things still to answer in the second half of the question. So what are these two halves? Well, the first half is sort of saying why it should be that these things that we call chances are the sort of things that we should defer to. Where defer to, I'm meaning in some very kind of informal, intuitive sense at that point, okay? Should somehow pay attention to, should listen to the verdicts of something like that, okay? And that's the first half. And I take it a lot of the work that's done kind of in the metaphysics of chance and so on is thinking about kind of what, and I think I kind of take it this was Lewis's project, was try to think of what sort of metaphysics of chance might you give that could make sense of why it would be that you would defer in some sort of informal sense, why these should be the sort of things that you should listen to in any sense at all. But then suppose we've answered that question, so that's bracketing a huge part of the question, but suppose we've answered that question. There still remains this question how you should defer to the chances, kind of precisely what the norm should be that link your credences about the objective chances with your credences about propositions that those chances assign probabilities to. And then there's a kind of a question after that, why should we defer in that very particular way? So I'll talk about the kind of two specific questions I'm interested in a little bit later on that come up from here, but just to give a little bit of a foreshadowing of that. So one question is this. When you first see the principle, I mean, Lewis does this beautiful thing at the start of the 1980 paper where he kind of he primes you up with a bunch of intuitive principles. If you were to learn the coin was fair, surely you would think it was 50-50 that it was going to come up heads. If you think that it's 70% chance of raining tomorrow, surely you would think you should have credence 0.7 that it's going to rain tomorrow. And those do seem sort of intuitive, but when you start to think about it, there's something very strange about it. And I think that some of the strangeness is kind of highlighted by Chris Meacham's talk earlier in the workshop. Because Chris was asking us, I understood the talk to be something like trying to tell us what it could mean to assign these particular precise numerical values to particular propositions and call those chances. And as he was alluding to, there's also a literature on exactly this question in measurement theory about credences as well. What does it mean to say that I have 0.75342 credence in this particular proposition? And we try to answer those using measurement theory as well. But however we answer them, we're going to end up with these two quantities, credences on the one hand, chances on the other. They're going to be measured on a particular scale. Yes, we traditionally and conventionally use zeros, and zero is the lower end of the scale, 1 is the top end of the scale, or 0% and 100% is the bottom and top end of the scale. But other than that, what reason have we for thinking that these two sorts of quantities are relatable in any particular way whatsoever? But of course, the principle, or the thing that Lewis is trying to kind of motivate us to believe in those sort of introductory pages to Subjectivist Guide, states a very, very precise relationship between them. If you were to learn that the chances were exactly this, then your credence, this other sort of thing, this other sort of quantity measured on some other sort of scale, not necessarily comparable sort of scale at all, should be precisely the same thing somehow, or same in some sense. But I think there's a big puzzle about that. So I think there's this sort of extra question, once you sort of come to the intuitive verdict that you should defer to chances, why it should be that you should defer in this very precise way that something like the principle says. So that's one question that remains. Another question that remains, if you're, for instance, a Humean, is how you should deal with undermining chances. So how should you defer to chances when you know that some of them, at least, are going to be what Lewis calls undermining chances. I'm going to call them modest chances here, but it's the same idea. Okay, so that's going to be, those are the two questions that I'm trying to answer. So I'm answering the second half of the kind of question about Chance-Credence principles. I'm kind of taking it at the point where you think there's some reason to defer to chances in some sense, but you haven't specified exactly what that sense is. And then I'm going to try to tell you why it should be that you should defer in this kind of precise way where these two quantities you shouldn't initially think would have anything to do with each other match up, and also try to tell you what to do with their undermining chances around. Okay, so here's an overview. Those are the questions, roughly, that I've just spelt out. I'm going to roughly just quickly go over a framework I'm going to use, a sort of formal modelling framework that we use for talking about the credences and the chances. I'm then going to go through 4 Chance-Credence principles. Just to sort of give an overview, I think 3 of them at least have been talked about. No, 3 of them at most probably have been talked about in the workshop so far, and I'll talk about the one that I favour. And then I'm going to go through 3 different styles of arguments that we can get out of formal epistemology for these sorts of Chance-Credence principles. Dutchbook argument, Dutchbookish argument. A pragmatic argument in any case that uses a lot of the machinery of Dutchbook arguments, and then 2 accuracy-based arguments. So I'll call the veritistic one and the aleatoric one, and we'll go into that in a little while. And then finally, I'm going to finish off, if I kind of keep to time, by talking about a further principle very closely related to these, but in fact weaker than the principle that Ben Levenstein, late of this parish, has talked about in a recent draft paper, and has given this really beautiful accuracy argument for. So in a sense, that's kind of, that last bit is a sort of advert for Ben's work, but also there's a kind of nice question which I'll come to, sort of the final slide will be, how can you tell which particular accounts of chance might favour each of these arguments more than which other accounts of chance? Because throughout the talk, I'm really going to be just totally agnostic about different metaphysics for chance. And then at the end, I'm going to say, well, given which ones you're interested in, which of these sorts of arguments might you favour for telling you which sort of Chance-Credence principles you should use? So I think Ben's is kind of an interestingly different argument from my arguments. Okay, framework. So the framework is going to be super simplified. That's really just for the purposes of kind of going through stuff quickly and not having to put endless kind of mathematically complex sort of caveats in at various points. You can remove quite a lot of the simplicities here and make it more realistic, but I'm not going to here. For the purpose of illustrating the arguments and how they work, I don't think there's any need to do that, but you can lift off some of these limitations. So the first one, I mean, basically the limitations are everything's going to be taking place in a very, very finite setting. Okay, so we're going to have some finite algebra of propositions, F, and you're going to have credences defined over that finite algebra. You're going to have chances defined over that same algebra, F, and within the algebra, and you're only going to have finally many of these chance functions, possible chance functions. Okay, so these are the ones that from the agent's point of view are sort of possible for them at the moment. So this is the particularly sort of unrealistic assumption here, that you've only got finitely many possible chance functions. Typically you will think that there's uncountably many possible chance functions. And then within your algebra for each of these chance functions, you're going to have some proposition which just says that's the true chance function. Okay, that's the chance function at the actual world. And we're just going to be thinking of you at a particular time, t, and we'll just take c to be your credence function at that time and e to be the proposition that expresses your total evidence. E is within this algebra. Don't worry if that isn't, you don't take all of that in at once. We're going to be coming back to these again and again. But essentially it's just a kind of very standard, quite simplified formal epistemology model, sort of Bayesian model for agents. And we're going to ask about what the constraints are on your credence function, the rational constraints on your credence function. Okay, so for instance, this might be the sort of algebra that we have. It has various propositions in it. Britain will exit the EU before 2200. It will rain in New Brunswick tomorrow. These slides will mention David Lewis. The coin toss will land heads. Those are the sort of first order, worldly sort of propositions. And then as well as those, you've got a bunch of propositions that say things about the chances themselves. Your chance function is CH, the chance of rain is 70%, the coin is fair. So you've got both sorts of propositions in your algebra. Okay. And final bit of setup is just to define three properties on that your chance functions might have. So these are sort of corresponding to what people sometimes talk about as undermining chances. So I'm going to call them immodest. You've got an immodest chance function in the presence of some body of evidence. The whole thing, I mean, slightly annoyingly, is going to be relativized to this body of evidence all the time. But in a way, you can just kind of forget that. Nothing's really going to hang on the particular body of evidence. You just need to kind of have it there to make the principles seem sensible. But so your chance function is immodest in the presence of a body of evidence. If it assigns that body of evidence, it gives that positive probability, and it's the chance that it assigns to itself being the chance function given that body of evidence is 1. So it's immodest. It's certain of itself. It thinks I'm definitely the chance function. So there it is, being immodest in its top hat. And then by contrast, you can have modest chance functions as well. We know all about these. This is sort of the thing that Lewis drew attention to in 1980 paper. Chance functions are modest if, again, it assigns positive probability to the body of evidence. But then if it's less than certain, it thinks there's some possibility of another chance function being the actual one. So this is the sort of one that typically people talk about in naive Humean views, where because whatever sort of non-extremal chances you have, they will give some positive probability to worlds at which the chance function of that world is going to be something different. Okay, so that's what it means for it to be modest. And then finally, you've got this very slightly different notion, which is a little bit subtle, which is when a chance function accommodates immodesty. So that's when it's modest itself, and at least one of the other chance functions that assigns some positive probability to is itself immodest. So you're typically going to get that in sort of Humean cases as well. So for instance, if I have a particular coin has a particular bias, I have a particular credence that it's going to land heads the chance that it's going to land heads is a particular amount. That's typically then going to give some positive probability to an entire string of heads. And that entire string of heads, of course, is then going to give credence 1 and chance 1 to the coin landing heads, and then chance 1 to itself being the correct chance function. So this is just as a little bit more than modesty. It says that something accommodates immodesty if it's modest and it thinks one of there's an immodest chance function that it gives some non-zero probability to. Okay. So here are the principles. So 4 ChanceCredence principles. So starts off in 1980. In a way, I suppose this is really Miller's principle, but given Miller thought there was an internal contradiction in it, it seems an odd thing to name it after somebody who thinks it's false. But this is and in this discussion much more known as Lewis's principle. So the principle says that your credence in a particular proposition, given that the chances are given by this function CH, are just going to be whatever that chance function CH thinks of X conditional on the evidence that you have. This is going to get around in an admissibility criteria because it conditions the chance function on E. Actually, this is a little bit weaker than the principle that Chris talks about in his paper. And I mean, I agree with Jack and with Chris that that's the right way to go. You can basically recapture everything I'm going to talk about using getting Chris's stronger principle, but I'll just use this here because it's just a little bit simpler for specifying these norms. But that's the standard or one standard way to see the principle. And then we have, so this is, it's interesting, I was calling this the new principle, but Jack was calling this the super principle. But in any case, it's the one that's basically the principle, but the thing that you're deferring to is not the chances, but what Jack was calling the super chances, what I'm calling the chance pluses, which is chance plus relative to a particular chance function is just that chance function conditional on the fact that it is the chance function. Okay, so then the new principle just says the same thing that the principle said, but instead of having the chances over on the right-hand side, it's the chance pluses. And that avoids the standard problems of the principle, which we'll see in a second. And so that was 14 years after Lewis's, and then in a neat symmetry, Nans was 14 years after that. The principle that she's already mentioned, the general recipe, which says that your credence in a proposition should be your expectation of the chances. So I should just go through all the different possible chance functions. I should take my credence in each of them and use that to weight the chance that chance function assigns to the proposition, and then sum them all up. And then, breaking the 14-year rule, I proposed what's essentially just a very small tweak of Nans principle, which I'm calling here the aggregate principle. In the book, I call it actually some horrible, unintuitive name. But that's just because I have about 30 principles I'm going through at that point, and there's just not that many intuitive names you can give them. But this is the principle I think now is the right one. Essentially what this says is not that your credence should be your expectation of the chances, but it should be some weighted average of the chances. It should be some mixture of the different possible chances that it could be. So your credence in X should go through all the different possible chances that the different chance functions assign to it, conditional on your evidence, and you should weight each of them and then sum them up. In one way, so in some sense it looks very similar to Nans. Basically, I've just got a sort of a weighting here, whereas Nans got your credence in that. But actually it ends up being way, way more permissive because you can set these really in any way you like. So the aggregate principle is actually quite a permissive principle in any case. And we'll see later on the reason that I like this. Well, one is I'm going to point out that there are particular problems that arise for each of the other ones, but then also the arguments that I'm going to enumerate, the Dutchbook arguments and the accuracy arguments, it's that one that they end up justifying. Okay, so what were the problems? So there's this standard thing of saying about the principle that it's somehow inconsistent if you have if you have modest chance functions or undermining chance functions. That's not really quite true. All that it does is it requires you, if there are undermining chance functions, to assign your credence in them being the chance function 0. There's no kind of inconsistency that arises. It just says that you can't possibly be. You've got to be certain that the chances are immodest. So that's what Lewis calls the big bad bug. And Holt's principle avoids that because basically the way that you derive that is just plugging this chance proposition into the position of X and seeing that those two sides can't match up. It's got to be 1 on one side because of the probability calculus, and then it's going to be less than 1 on the other side. And Nans Principle avoids that just by conditioning on the chance proposition over on this other side anyway, so that they can, in that situation, match up as both assigning credence 1 when you replace X with this chance proposition. The problem, which has come up a couple of times, Janan mentioned it, and then I think Jack just mentioned it in his talk as well, is that this just isn't the way that we in fact defer to chances. When I tell you that the coin has bias 0.7 and then I ask you to kind of make a prediction about or set your credence concerning what you think your credence in a particular run of heads or tails is, you just use the chances themselves. You don't use the chances after having first updated it by the fact that they are the chances. Now, as far as I can see, the thing that persuaded Lewis that this wasn't such a problem was that essentially in a lot of situations things aren't going to go too badly wrong just by using the chances rather than the chance pluses. Sorry, if you use the chance pluses, then you'll avoid this inconsistency, and also you won't actually deviate too far in most normal situations. But nonetheless, as philosophers, rather than engineers, we're not always kind of content with solutions that just approximate the right thing to do. We'd like something that gets it exactly right. Okay, so fast forward 14 years and we get Nans Principle. Problem with Nans Principle is, again, the same sort of problem arises. And all these problems sort of arise because the they sort of arise for a Humean account. Because on that account, the chances are going to be the sort of things that assign chances to the chance propositions themselves. That's not going to be true for all accounts of chance, typically. But because they do that, because, of course, the chance propositions just supervene on the kind of non-chance mosaic, the chances are going to have some sort of opinion about those chance facts. And so you can just plug in the chance proposition here and in here, and it turns out that if the chance proposition accommodates immodesty, so not you have to go a little bit further than it just being immodest, which is what you needed up, or being modest, which is what you needed up here. But if you just have that it accommodates immodesty, then again it's going to require you to assign zero credence to that. And actually there's this further kind of interesting concern that comes up here that that this principle, which makes it different from the other ones, doesn't get preserved by conditionalization. So you can start off, in fact this will typically happen, you start off satisfying the general recipe and you update by conditionalization, you'll no longer satisfy the general recipe. And that's a bit of a problem because we've got various reasons for thinking that conditionalization is the right way to update. It's not, I mean, I don't actually think that's particularly fatal. You could just think that the thing you should do is just always update these by conditionalization and then set the rest of your credences that way. But the typical arguments for conditionalization give reason for updating the whole credence function by conditionalization, and so that's going to avoid that. Are there problems for this other principle? Well, in a sense, it hasn't kind of been tested long enough. It's only 3 years old, and it's not really had a huge amount of discussion. I haven't thought it through much more. There may well be kind of big problems for it in the future, but let's leave that for the future. Okay, one thing to just say, just to avoid any confusion, if the chances are immodest, so if there's no undermining chances, then basically all of these principles are equivalent. They're all the same principle. The interest is going to arise when they're modest. And so what I'm going to do for the kind of next little while of the talk is I'm just going to talk about the case where their chances are immodest, so everything's just the same, principle's the same as Nans, is the same as Ned's, is the same as mine. Okay? And I'm going to try to give arguments for that. Because what I'm interested in the next little while is answering this sort of question. Why should the chances and the credences match up so neatly, or match up in that particular way that these sorts of principles say, given we shouldn't really expect that to begin with, because these are different sorts of quantity. One some sort of physical quantity, one some sort of epistemic representation of someone. Why should you think that they kind of have this neat matching up that we typically think they do in Chance-Credence principles? And then later, having gone through these arguments, I'm going to lift off that restriction or lift off that assumption that we're talking about the immodest chance functions, and then we're going to ask, what do these arguments tell us about the question of how should we do our deferring when we have modest chance functions? Okay, so I'm going to go through these 3 arguments, Dutchbook, 2 sorts of accuracy argument. So how do they go? In each case, I'm going to explain how the standard argument of this sort goes for probabilism first. Okay, so in both cases, the most famous, the most well worked out, the best studied argument of this sort is an argument for probabilism. So the norm, the creedal norm that tells you your credences should satisfy the probability axioms. So I'll go through that, and then I'll show how you can adapt that framework to give an argument for of this sort for the principal. So here's the Dutchbook argument. It's the standard sort of pragmatic argument, and the idea is this: look, we've got these things called credences. What are they good for? What do they do? What role do they play in our lives? And the thought is, well, here's at least one sort of role. They're meant to be, Butler calls the guide, probabilities, the guide to life, or they're the sort of things that are supposed to guide the decisions that we make. They lead us to choose particular things. And what the Dutchbook argument is going to show is that if you don't satisfy these particular norms, then your credences are going to guide you in life worse than they otherwise would. Okay, so here it goes. If you violate probabilism, so if you've got a credence function that violates probabilism, there's a finite series of bets, because we're kind of working in the finite framework, this kind of holds across to infinite cases as well, but we're just thinking here of the finite case. So if your credence function violates probabilism, there's a finite series of bets such that two things are true. First, your credence function is going to sanction accepting every single one of those bets. Now, of course, there's an assumption built in here about what bets particular individual credences sanction, and that's a place where some people get off the boat when it comes to the Dutchbook argument. But let's just assume this for the moment. So your credence function is going to sanction accepting each of these bets individually, but when you look at them together, they're going to lose you money at every single possible world. Okay, that's standard Dutchbook argument. Now, this may look like overkill, but I'm going to go through the kind of mathematical, very, very, very diagrammatically, the maths behind why the Dutchbook argument is true. The reason is that basically this single bit of maths is going to occur again and again and again. It's going to be our argument for everything, really. Okay, so how does it go? Well, the first thing is we start off with the set of valuation functions. Okay, so what's this? So remember what we had in our setup. Here we are. Remember we had a set F. Of an algebra of propositions. So what are the valuation functions? They're all the ways of assigning truth values to the propositions in that set in a way that's classically consistent. So just think of them like the classically consistent worlds specified with sufficient precision to give a truth value for each of those propositions in there. And their valuation functions, what are those? Well, they're just the kind of true-false function, but with 1 and 0 instead of true and false. Okay, so they assigns 1 to all the truths, 0 to all the falsehoods. Those are the valuation functions. And basically, this whole enterprise is founded on one incredibly beautiful foundational result by De Finetti, which is the probability functions over this algebra are precisely the convex combinations of the valuation functions. De Finetti proves this, well, back quite a long time ago. And it's basically the basis for all the Dutchbook arguments and all the accuracy arguments. So you take, there you go, you've got your convex hull of valuation functions. That is exactly the set of probability functions. Okay, so if I have a credence function that lies outside it, there's one, call it C. We can then appeal to this other bit of maths, which is sort of crucial and comes up a lot in these, called the separating hyperplane theorem, which notes that given this is itself a convex set, well, it's a degenerate one, it's just one point, and this is a convex closed set. We're in a finite case, so this is going to be closed. You've got a hyperplane that separates them. Don't worry too much about kind of what that means. What the theorem ends up giving us is the existence of a particular vector that just goes up perpendicular to this and away from the hyperplane coming out of C. And this, kind of, you might think, why on earth is this kind of is getting mathematically more complicated than I might have expected from an argument that looks reasonably straightforward. But the point is that this gives the set of stakes on the bet going to be presented with. Because remember what the Dutchbook argument says. It tells you if you have a credence function that's not a probability function, then I can find some set of bets such that you're going to accept each of the bets, but in total they're going to lose you money. So notice there's that existence claim there. There's an existence claim that says if you don't satisfy the probability calculus, then I can find some series of bets. How do you find that series of bets? Well, this separating hyperplane thing tells you this, it gives you this existence fact. It's this set of stakes. Or this is one that will do the job. There are uncountably many of them, but that's one that will do the job. So take that. Why does it do the job? Well, the point is this. Now take a valuation function within this convex hull of valuation functions. Okay, so let's take it to be W. And now take this vector, okay, which is this minus that. Then what the kind of purpose of the separating hyperplane theorem is that once we have this thing, because it's perpendicular to this and this is separated from that, the angle of this is going to have to be obtuse. Okay? It's going to have to be more than 90 degrees. And we know from various bits of linear algebra. You can do it in a number of different ways. But one thing that we know from that is when you have two vectors like that have an obtuse angle, the dot product of them, this thing, dot product with this, is going to be negative. It's going to be less than 0. Okay, why is that interesting? Well, because it then gives us this fact. It means that the set of the vector of stakes, dot producted with the valuation functions, is going to be less than the set of stakes dot producted with the credence function. Why is that interesting? I mean, it's kind of neat, but why is it of any interest? Well, it's of interest because this side is how much you will pay in total for the set of bets, and this is the total payoff of the set of bets when taken together. If people are interested, we can kind of go through the details of that. But I'm kind of sketching through because we're going to use this sort of framework again and again. But the kind of details of the maths aren't particularly crucial, but I thought it'd be quite neat to sort of show how things work. But the point is, this is how much you would pay for that bets with that stake. This is how much you would get from it. Given this is always going to be less than this, you're going to pay more than you're ever going to get back, so you're guaranteed to lose money. Okay, this is going to be true of every single world within this. That's what the separating hyperplane theorem gives us. So we get the Dutchbook argument for probabilism. Great! But that's nowhere near the principle. Now the principle. How does the Dutchbook argument go for that? Well, you're not going to get an argument exactly like that last one, because there is a converse Dutchbook theorem which says that if you are in the set of probability functions, so if you satisfy probabilism, there's never going to be a set of bets each of which you'll accept and that will lose you money for sure. That's the converse. That was Chimney or someone back in, or Kemeny was in the 60s. Anyway, 50s and 60s. So there's a converse. So we're never going to get that, but might we get something similar? And the answer is yes. So here's the fact. If your credence function violates, well, probabilism and the principle, okay, we can kind of assume from now on we're just working with probabilistic credence functions because we've got some other arguments for that. But if it violates the principle, then it turns out there's a finite series of bets such that the following thing's true. Your credence function, again, is going to sanction accepting each of those bets. Right? So that's just exactly like the first argument. But taken together, those bets are not necessarily going to have negative value, but they are going to have negative objective expected value, regardless of how the chances are. So there's going to be a set of bets, you're going to accept every single one of them. You don't know what the chances are, but you do know that whatever the chances are, they expect you to make a loss. Okay, that's the kind of Dutchbook argument for the principle. And I mean, this is the bit of maths is basically just exactly the same. I'm not going to go through it in much detail, but what I just want to highlight is what it depends on is swapping out the convex hull of the valuation functions, which De Finetti had shown as exactly the probability functions, for the convex hull of the chance functions. Okay, I'm saying this because it's going to come up, kind of going to be important later on. So you swap it out for this, and it turns out, so we now want a theorem like De Finetti's, but now for this set of credence functions. What's the theorem? Well, it's just that the ones that satisfy the principle are precisely the credence functions that sit within this set of credence functions. Okay, this is assuming we have just immodest chances at the moment. Okay, so yeah, you get the similar sort of thing, but now instead of valuation functions, you have chance functions, and then this is just going to be the objective expected payoff of the bet, and this is going to be the price you pay for it. So the objective expected payoff is going to be less than the price that you pay for it. Therefore, you're going to be always expected by the chances to have a negative payoff. Right. So why is this interesting? Because of that question that I was saying we're kind of initially interested in asking. The metaphysicians, the particular accounts of chance, are going to have to kind of do the first half of the argument for the principle. They're going to have to tell us why there's some sense, something about these chances that are the sort of things that we should pay attention to their verdicts. Okay. The accuracy stuff is not, well, the Dutchbook stuff is not on these arguments going to give you that. But here's a very minimal thing. If you tell me that there's some sort of thing out there, chances or God or what have you, that is the sort of thing that I should pay attention to the verdicts of. Here's a really minimal conclusion from that. If those things speak univocally, if they speak with one voice about a particular issue, I should do that thing. If they, if they all agree that this alternative thing is better than, or this, if they all agree that this particular thing I'm about to do is bad, then I should pay attention to that and think of it as bad. And that's essentially what's going on in the Dutchbook argument for the principle. It's saying, look, if you violate the principle, then there is this series of bets. I'm going to accept all of them, but every single one of the chances is going to tell me that it's the wrong thing to do. And that's what underpins the irrationality. So if someone can kind of give us the first half of the argument, namely there's some sense in which you should listen to the chances, you should pay attention to their verdicts, then that gives us this very, very minimal conclusion that we should at least do whatever all of them think is the right thing to do, or we should not do something that all of them think is the wrong thing to do. And then you can plug in this argument to show that you should satisfy the principle in this very precise way. So that's one way of answering this question. Why is it that the chances and the credences should match up in this very nice way? That's one argument. Here's the second argument. I actually didn't figure when we started.
A little after 11:40, like 20 minutes.
I've got 25 minutes left, or have been going 20 minutes left. Perfect. Okay. Okay. Oh, that's good. So that's one argument. Here's the second argument. Actually, I'm going out of order with these. I wrote there's two accuracy arguments for the principle. The first one I wrote up I called the aleatoric argument. I'll come to that in a second. But I'm going to stick with the veritistic argument to begin with. Partly because that's the one that most naturally comes out of the accuracy argument for probabilism. Okay, so let's start off with that. So this is Jim Joyce. He's really building on a mathematical result that De Finetti proved in the same kind of same work that he proved that theorem that I was referring to earlier. But now Joyce is taking what De Finetti had, which was essentially a new pragmatic argument for satisfying the probability axioms, and he's giving it an epistemic twist. Okay. So for De Finetti, it was all about how to avoid losses, how to avoid losing more money than you need to. For Joyce, it's all about being as epistemically good as you can be. So I mentioned before, credences have a number of different rules. One of them is they guide our actions, right? And we saw that at work in the Dutchbook Argument. But they have this other rule as well, which is often, well, until Joyce, was sort of downplayed in the kind of Bayesian epistemology literature. And that other rule is just to represent the world. We're trying, one of the things our beliefs do, and our graded beliefs are going to be no different, is just try to say what the world's like. Try to represent with as great accuracy and precision as we can the way that the world in fact is. It'd be very surprising if we had these sort of doxastic states that only played pragmatic rules, didn't have any of this alternative kind of representational rule. So Joyce thinks, I mean this is kind of Joyce star or something like this. This isn't entirely how Jim would present it, but roughly Joyce thinks something like this. Okay, so we're trying to get credences that represent the world. That's one of the things, it's one of the roles they're meant to play. That's one of the things we're trying to get at with having credences. What would be the best possible way they could be to represent the world? And the thought is, well, they could be omniscient. That is, they would assign maximal credence, that's going to be 1 or 100%, to everything that's true, and 0 or 0% to everything that's false. If you had those credences at a particular world, then you would be doing just as well as you possibly could be. That's the goal, that's the dream, that's what we're all after. That's what the aim of inquiry is. Okay, so for each possible world, we have this kind of omniscient credence function. Now, no coincidence, it's exactly those valuation functions we had from the previous thing. It's the things that assign 1s, or 100% to all truths, 0% to all falsehoods. Okay, as we'll see, that's not a big coincidence. So Jim thinks, okay, there's that. There's the goal of having credences. It's representing the world perfectly. That's what it means to represent the world perfectly. But it's not an all or nothing thing. I think in the original paper, Jim has this thing where he says something like, a miss is not as good as a mile when it comes to having accurate credences. You can be more or less accurate. If Janan has 99% credence it's going to rain tomorrow, and I have 5% credence it's going to rain tomorrow, and it does rain tomorrow, Janan's just doing better. She represents the world better. Neither of us are perfect. we would have been perfect had we had 100% and it raining tomorrow. But nonetheless, Janan's doing better. She's closer to that omniscient agent than I am. She's doing better at getting at the goal of inquiry or the goal of having beliefs than I am. So, in order to say how well you're doing epistemically speaking, you need to measure the distance between your credence function and the omniscient credence functions. And how far you lie from the omniscient credence functions is going to be your inaccuracy. How close you lie is your accuracy. And we have a kind of class of ways of measuring those things, and there's arguments for why that's the ways of measuring them. I'm not going to go into that at all. Though happy to talk about it if people are interested in those sort of technical details. But nonetheless, those that's how we get these measures of veritistic inaccuracy. Okay, and then having done this, well, Jim using a particular way of characterizing the measures of inaccuracy, and then a group from Princeton of sort of computer scientists and engineers using a different set of measures of inaccuracy, basically the ones I'm going to use here. They showed the following thing. Suppose you violate probabilism, okay? So suppose you don't satisfy this epistemic norm. Then it turns out there's some alternative credences you could have had defined on exactly the same propositions that yours are defined on that are guaranteed to be better than yours are. Okay, so they do better for sure. They're more accurate for sure. And this diagram's really going to get old, but turns out pretty much the same bit of maths is going to show us why that's true. Why is that true? Okay, so we're back to the probabilism case. So we're convex hulls of valuation functions now rather than of chance functions. So valuation functions are now basically omniscient credence functions. They're the kind of, for each world, they're the kind of best thing you could possibly be. Take the convex hull of them. That's the probability functions. Suppose I lie outside. Then this time, I mean, the line goes a different way, but it's essentially the same thing going on. Take the nearest credence function in this set to the one of yours that lies outside it. Call that C star. Then you can show that the inaccuracy of this thing is guaranteed to be less than the inaccuracy of this thing. Okay. I mean, essentially the same bit of maths, but it just looks slightly different here. Not exactly the same, but you do need something a bit different. But okay, but you can sort of illustrate it in the same way. This thing here, this alternative, is going to be better however the world is. So it's a single thing that is better regardless of how the world is. It's kind of important the way the quantifiers are there, right? For anything outside, there exists something here that's better for all worlds. What's obvious is, if you've got something here, then for any possible world, there is something that's better than it. But it's a much stronger claim. The claim is, if there's something here outside that isn't a probability function, there's something that is a probability function that's guaranteed to be more accurate. Okay, so that's supposed to give you probabilism. What does the argument for the principal look like, the veritistic one? Well, I mean, again, there's a converse to Joyce's argument for probabilism. If you are a probability function, then there's never going to be something that dominates you. Okay, so we're never going to get that for the principle. Okay, because we know there are probabilistic credences that don't satisfy the principal. But you do get something which is very analogous to the Dutchbook sort of case. If you violate the principal, there's going to be some alternative thing, and it's not guaranteed to be better than yours, but it is guaranteed to have better objective expected accuracy than yours. That is, every single possible chance function is going to expect that thing to be better than yours. So again, if you have an argument that shows that you should defer to chances in some sense, that is, in the sense that if they all speak with one voice, you should go with what they say, then this sort of argument is going to give you that you should satisfy the principal, because if you don't, there's some alternative thing and they all unequivocally say that thing is better than you are. That looks irrational. Okay, I'm not going to go through that. But it's basically the same bit of maths, just substitute the chances in for the valuation functions. Okay, so that was what I thought in 2013. 2012, I thought something slightly different. So the argument I just gave Joyce's answer to the question, what does it mean to say that a credence function well represents the world? Namely, it well represents the world the closer it comes to these omniscient credence functions. But there's another answer to it. So Al Hayek poses the question in kind of typically Hayekian, kind of beautifully elegant form by saying this. Look, what is it that stands to credences in the way that truth stands to belief? When we're talking about full belief, there's kind of no question. The best thing you can do, the thing that kind of counts as kind of vindication for beliefs, is them being true. Okay. Move over to credences, it's not so obvious. Joyce gives this very particular answer. He says, no, actually it's the same thing. The thing that stands to credences beliefs, as truth stands to belief, is truth. What you should try to have are kind of, well, true is probably not quite the right way, but maximally accurate credences in the sense of being closest to the omniscient credences. Hayek thinks maybe not. Maybe instead the right thing for credences to try to approximate are the chances. So this is a kind of graded, they're both graded notions, and perhaps that's the right thing to do. Okay, so how would, and then, so if we were to take that instead of the veritistic account of kind of what it is for, what credences are trying to aim at, if we take that, then what sort of, can we give an argument for the principle? And the answer is that we can. I mean, in a sense, this one's probably much less surprising than the other ones. If the things that I'm trying to get better and better at is approximating the chances, then we can give this quite straightforward and much more powerful argument for the principle. Because if you violate the principle, there's going to be some alternative credence function that's guaranteed, oh god, that shouldn't be like that. Ignore that. That's guaranteed to be closer to the objective chances than you are. Okay, you're guaranteed to be more accurate. Not you're guaranteed to have lower expected aleatoric accuracy. You're guaranteed to have lower aleatoric inaccuracy. See. Okay, where aleatoric accuracy is getting close to the chances, while veritistic accuracy is getting close to the omniscient credences. So that's going to give quite a quick argument for that. I mean, essentially, here's the argument. It just looks exactly like the argument for probabilism, but now with chances in this set rather than the omniscient credence functions. It just says, look, the convex hull of the chance functions is precisely the things that satisfy the principle. Now, I suppose you're sitting outside it, then there's something inside it that is closer to each of the chance functions. But that's what you said accuracy was, so these things are closer. So if you take this kind of Hayekian aleatoric view of accuracy, then you're also going to get an argument for the principle. Okay. So that's supposed to be an argument for why, if we've already got to the stage where we think that there's some way in which we should defer to the chances, that is, we should pay some attention to them, then it's meant to move from that conclusion to the kind of personification of it, or personification of the kind of weakest consequence of it, namely, if they all have a particular opinion, you should also have that opinion, or if they all recommend a particular way of acting, then you should act in that way. If you take that, then we're going to be able to give accuracy or Dutchbook style arguments for the precise version of the principle. And that answers the question, why should it be that chances and credences, despite the fact they're different quantities measured on different scales, or needn't even be commensurate in terms of the scales that they're measured in, why they should come to match up in this very particular way. That whole story was kind of told with an assumption of immodesty. Okay. What happens when you lift that assumption of immodesty? What happens if you don't assume that all the chance functions are immodest? You allow in the way that Humean does, some modest chances. Then it's not going to be terribly surprising because of what we saw in each of these different diagrams. Remember, the thing that that these arguments really justify is the claim you should be inside the convex hull of the things that you're trying to approximate. So if you think those things you're trying to approximate are the omniscient credence functions, valuation functions, then the thing that you should be inside is the convex hull of the chance functions. That's what each of the different arguments, the Dutchbook argument, veritistic argument, and the aleatoric argument, they all give that conclusion. You should be inside that convex hull. Now, when the chances are immodest, great. That convex hull is precisely the things that satisfy the principle, the new principle, Nans Principle, and the aggregate principle. Lift that, though, and suddenly that's not going to be the case. suddenly the things that it's going to justify are precisely the things that satisfy what I was calling the aggregate principle, okay? The ones that are just these convex combinations of the possible chance functions. So if chances are immodest, then that thing, the aggregate principle, entails Nans and Ned's and Lewis's principle. But if it doesn't entail any. Now you might think, and I thought this, and somewhat depressingly I'm in print saying this, but that's philosophy, that you could get something like Nans principle if only you assumed, if only your metaphysics of chance gave a particular feature of those chances, namely that the chances expect themselves. That's what I call self-expecting. That is, any particular, so suppose I have a particular chance function, a particular proposition, that the chance it assigns to that proposition is its own expectation of the chances. So, of course, remember, in this setup, the chances have opinions about all the different possible chances. So they assign credences to all of those, so they can have expectations of what the chance of a particular thing is. So you might think, a natural thing to think is, surely the chances should be self-expecting. They should expect themselves to give the chance. It'd be sort of odd if the chance gives out some verdict on a proposition, but also expects some other verdict to be the chances. Sounds odd. I mean, in a sense, that's no odder than what modesty is in the first place. But you might think that's going to be the right thing. Okay, so you might want this for all chance functions. But then, very recently, so I'm kind of gratified that it took at least 3 or 4 years for someone to notice the problem. Jonathan Weisberg has a very lovely proof on his blog that in fact everything that's self-expecting is already immodest. So basically, there's no such thing as a you can't have some sort of middle way between modesty and immodesty that is this self-expecting. Just isn't there. I should have put a link to this up here that might not have been so useful. Anyway, just go to Jonathan's blog. It's an incredibly elegant proof that uses this kind of really neat result in linear algebra to show that. Okay, so you're not going to be able to get that out. So, kind of 5 minutes? Oh, 10 minutes. Oh, God. This went way over when I tried it. Okay, I obviously went through more of the maths than I have. So you've been spared. Okay, so I'll come at the end then to this this nice alternative principle that Ben Levinstein has. And this is, I mean, I was taking the kind of workshop spirit of this sort of wholeheartedly. This is sort of advertising really nice work rather than kind of saying anything particularly new about it. I will say a couple of not new things about it. I'm sure Ben anticipated them all, but some commentary on it. But anyway, it's sort of intriguing recent stuff. Okay. So here's what. So actually, Ben calls the trust principle. This is building on work by Kevin Dorst. Kevin's interested in this, in actually the kind of rational kind of reflection and that sort of area. But it's a deference principle. I mean, these deference principles, there's all sorts of them all over the place. Things like new rational reflection, and so on. But Kevin's interested in them in that particular case. Ben's interested in the chance case, though actually his result there's nothing specific to chance about it. It's just the way that he's framed his paper. But here's the principle. It looks shockingly like the principle, but not quite. Your chance in a particular proposition X, your credence in proposition X, conditional on the chance of it being greater than or equal to X, once you've included your evidence, should be greater than or equal to X. Sort of looks like we should be able to get the principle from that, shouldn't we? But it seems not. Partly because this doesn't tell you anything about what happens when you put in both this inequality and the reverse of it, which is what you would kind of need to derive the principle. In any case, there it is, the trust principle. Looks sort of plausible, weaker than the principle. What can we say about it? Well, Ben's got this very, very elegant accuracy-based argument for it. So, the thought's this. Suppose you're looking out on all the possible chances. Okay, you're looking out as chance as a thing, and you have different expectations about different credences and what those chances might be. Now suppose that you expect the chances to do better than you, epistemically speaking. Now, in the accuracy framework, that's never going to happen if you know the precise value of the quantity that you're interested in. So if I know Adam's credence, then I'm never going, and it's different from mine, I'm never going to expect his to be better, because there's this assumption, sometimes gets called propriety, or strict propriety in the accuracy literature, that says that my particular credence function should expect that credence function to be uniquely the best. So if Adam's is different from mine, then I'm never going to expect his to do better. But it doesn't rule out a situation where you don't know, you know only a de dicto description of a credence function like the chances or the truth, or, I mean, if say I don't know Janan's credences about certain things, Janan's credences. It doesn't rule out at all that I could expect those to be better than I expect mine to be. In fact, the Hilary Graves and Davis Wallace argument for conditionalization is essentially based on the fact that you're going to expect your updated by conditionalization credences to be better than your current credences if you think you're going to learn a particular from a set of propositions in the future. Okay, so it's possible that I might expect some other thing, let's say the chances, to be doing better than me. Now, I suppose you do expect that, but you don't just expect it for one particular way of measuring accuracy. You expect it for any of the legitimate ways of measuring accuracy. Now, of course, it depends how you specify what those legitimate ways are, but let's just assume that we take the ones that are standardly used in accuracy theory, essentially the strictly proper scoring rules are what the ones generated in this way. Then Ben shows if you do that, then you will satisfy this this trust principle. So if I think of a particular sort of credence function, like the chances, that's going to be different at different worlds, and I'm not certain exactly which one it is, then I will expect, if I expect that to be better than mine, then I'm going to satisfy that principle. So that's an argument for that principle. Okay, so that's really nice. So the final question, I suppose, is very workshop style, sort of throwing it open to those who know a lot more about these metaphysics of chances, different accounts of chances than I do. Can any of those accounts make use of the results that I've just been talking about? So this is kind of the pharma rep coming along and saying, you got any problems that my drugs might solve? And so, okay, so here's a couple of possibilities. So there's two sorts of things you might, two sorts of ways that they might become relevant. One is if you have some reason for thinking that the chances, whatever they are kind of the best available decision-making probabilities that we have around. If you think that, but but other than that, that doesn't necessarily tell you that you should have those as your credences, because there's other purposes that credences, other roles that credences play. They're not just decision-making probabilities; they're probabilities for representing the world as well. But suppose you have some reason for thinking that, then it looks like you can then piggyback on the argument I was giving for using either the Dutchbook argument for the aggregate principle, or the veritistic accuracy argument for the aggregate principle. Because in both cases, those relied on saying, look, if the chances all think of one option as better than another, then you should go with that option. So if you've got some reason for thinking that, and I put propensity account, but I don't really know enough about it to say anything with any authority, but if you think something like that, then these sorts of arguments are going to give you arguments for the aggregate principle. Or you might think that chances are the best representations we have of the world to which we have access. So for instance, Janan, I think it was when talking kind of in the Q&A around Katie's talk, was saying, well, look, perhaps we think of chances as sort of the things that carry information, sort of as much information as is available at a particular point about the world. Well, okay, so suppose you think that. So you think in some sense they're kind of the best representations of the world to which we have access at the moment. There are better ones, namely the full kind of representation of the worlds, but these ones are somehow the best that we have so far. Well, in that case, you could either go Ben's way, okay, because in that case you think that essentially does just give you straight away the premise of Ben's argument. If you think of these things as doing better than you, accuracy speaking, if you think they're the best available representation of the world, then you should expect them to be doing better than you, and then Ben shows that you should satisfy the trust principle. On the other hand, you might think, well, look, if they're the best available representation of the world, then that's the sort of thing I should be trying to get close to, actually, for kind of for accuracy-ish sort of reasons. I should be trying to get close to the best representation of the world, because remember, that's what my that was what this role of credences was supposed to be. It was supposed to be, it's not just supposed to allow us to make decisions, but also allow us to represent the world. And if these are the best representation of the world, then I should try to get as close to them as possible. But then, of course, you've got the aleatoric accuracy argument for the aggregate principle. Okay, so that's it, really. So what I hope this does, like I say, I essentially feel like I'm kind of coming in for a consult, or to kind of give techniques. And part of the reason is that looking across the sort of metaphysics of chance, justifications of the principle stuff, kind of about 5 or so years ago when I was thinking about this, these arguments, it struck me that there were a lot of the arguments kind of gave good reasons for roughly thinking that we should defer to the chances. But emphasis on the roughly, or kind of, they were gestures towards why the chances were the sort of things that we might pay attention to. But they then didn't go the next step to saying why we should defer to them in this very particular way. Okay, I mean, Jack and David's thing is definitely going to give us some way of doing that, but only by trivializing them. So the purpose of this is just to sort of say, well, if you can get to that step, which I'm under no illusions is the big chunk of the difficult project, stuff that we've been developing in formal epistemology can kind of take you the rest of the way. Okay, so I'll finish there. Thanks very much.